Welcome back. We're going to go ahead and move on to our second kind of loop in processing, which is the for loop. And to set the stage for that, let's think about something here for a second. Let's suppose that we wanted to use a while loop that iterated 10 times every time it was executed. In other words, we want to use a while loop in a counting type situation, where we'll do something 10 times or 20 times or 150 times, whatever the number is, but a fixed number of times. So let's sketch out here how we might have to do that. First off, we would need a counter, some variable that we would increment by 1 each time the loop iterates. And since it's typical or customary to count starting from 0 in processing, we'll initialize the value of that variable to 0. The reason why we use 0 will become apparent when we get into the arrays chapter, chapter 7. Then we would begin our while loop. And in this case, if we wanted to go 10 times, we'd say while I is less than 10. And that's our loop test. And then we would have our loop body, okay, whatever it does. Maybe it's drawing circles, or it's drawing targets like in the textbook, whatever. Some sort of loop body is there. And then down at the end of that loop body, we have to remember to go ahead and increment our counter by 1, because otherwise our loop condition would never become false, and then we would have an infinite loop. Okay? So that's not so bad. We create a counter variable, initialize it to 0, check its value, and then increment the counter at the end of the loop. Now the difficulty comes is when this loop body is long. Then we separate the 3 things that are involved in our counting loop by a lot of code, right? The initialization, loop test, and the increment part would all be separate lines, and again maybe separated physically by several dozen or hundreds of lines of code depending on the size of this while loop, and probably not that big, but in any case. So let's look at that in flowchart form and see what it looks like. We come in, before the loop we initialize our counter variable, then we test that control expression. It's still a pre-test loop, so if that control expression is false, we fall out and we don't do the loop at all. Okay? Well, if we come in after the initialization, check the control expression and it evaluates to true, then we execute the loop body, update the value of the counter, and then go back to the control expression. Okay? Well, hey, wait a minute. This is this flowchart for a for loop, but it also matches that while loop structure that we looked at previously. So what's going on? Well, I told you this was a transition idea here. So let's take a look at this for loop in a little bit more specific detail. Our second pretest loop in processing, the for loop, what it does is it concentrates all of that counting information into one place. All these pieces are on one line at the beginning of the loop. The initialization of the loop counter, the test for its test expression, and the loop increment value. Okay? So if we go to the previous slide, notice that we do the initializing only once, then the control expression and the update, those happen every time the loop is executed. Okay, so at the beginning, we initialize our counter variable, and then we enter the loop. The control expression and the update then happen repeatedly until the control expression evaluates to false. All right, so let's look at the syntax then for our for loop. So again, what it does is it initializes, or concentrates rather, all of those 3 things, the initialization, the test expression, and the update expression, into one line. Okay? Those 3 pieces are separated by semicolons, which is very important to understand. So that looks a little odd. It's a different syntax than we've seen before because we have multiple things in the same statement that are separated by semicolons. And notice that there's no semicolon after the update expression. Then we have the loop body. Okay? So when we're programming with for, we can look at that first line and we can see everything that's important about the loop right there, rather than having it be spread all over the place like in the while loop. And that makes it a little bit more suitable in counting situations. Our statement here, or our loop statements, the body, can be one or more things. If it's only one statement, we wouldn't have to have the curly brackets, but in our case, or in our style, we'll use curly brackets all the time so that we don't ever have to worry about forgetting them. Okay? So, before we move on to our practice example, we also have to talk about the idea of scope. Scope describes where entities are visible in a program. And entities are just a fancy word for variables, methods, class names, object names, things like that. And so far, we've seen several different kinds of scope. Okay? Class scope, otherwise known as global, that would be used for variables that are declared outside of any method in processing. And those variables then can be seen anywhere. Block scope, otherwise known as local variables, are things declared inside curly brackets, and those things are visible only inside the curly brackets. So any variable that we declare inside a method only exists inside that method. It doesn't even exist outside of that method. Okay? That's block scope. And here's our new one, for loop scope. In that initialization expression in the for loop, a variable declared there is visible only inside the for loop. And so we don't have to worry about that counter variable outside of the for loop. It's local just to the loop. Okay? Now, when should we use this? Well, I've kind of given it away through the description that we've done so far. A for loop is a good choice when we're iterating based on some count. So when we have a counting style loop, a for loop is a good choice. Okay? All right, so now to wrap things up with the for loop, what we're going to do is go to another video where we repeat our previous example, and what we're going to do is a for instead of a while loop. And to emphasize the idea of counting with the for loop, instead of drawing a trail that goes all the way up diagonally until it reaches the edge of the screen, we're always going to draw 5 circles. Okay? All right, so in our next brief video will be a quick design and implementation of that program. All right, see you then.